Okay, now we'll be talking about three different types of charging. Charging in this case means taking an object that was originally electrically neutral and giving it a net charge, or taking an object that had a net charge and changing that net charge. The first method is charging by friction, and this is very simply put. This has to do with electrons being transferred from one object to the next by objects sliding past one another. Okay, so I'm going to get right to the example. Let's say that we start off with some sort of neutral stick. Neutral stick. We know again that it's neutral because I'm going to draw an equal number of positive and negative charges on it. Two positives, two negatives. Obviously in the real world this would be many more, but we're just trying to be simple here. And this, and we can do this in class because I have these materials, is a piece of neutral fur, like from an animal. Okay? Now, if you were to take the stick and the fur and slide them past one another, rub them on one another, so slide past one another, what could happen is something like this. Okay, there's our stick. Here's our fur. Remember, the positive charges will not move, so we still have the two positives here and here. We still have our two positives here and here. But depending on the type of object that, the types of objects, it depends on both objects. Depending on the types of objects that we have, we can transfer electrons from one to the other. And it will always be from one particular object to the next. It depends, again, that's why I was saying it depends on the objects. In this case, depending on what the stick is made out of, the stick could actually take those electrons from the fur. Okay, so those electrons, after they were, the stick and the fur were rubbed together, after they slid past one another, the electrons were transferred from the fur to the stick. The stick is now negative. Negative stick has a charge of negative 2e because it has 4 electrons, 2 protons, so the net charge is negative 2 elementary charges. The positive fur, because obviously it's positive now, has a charge of positive 2e. So we see that we start off with two neutral objects. Because of charging by friction, they are now both charged. But I do want to point out that charge was conserved in this example. So as far as conservation of charge goes, even though the fur lost 2 electrons, those electrons didn't just disappear. What happened was that the stick gained 2 electrons. So there's a conservation of charge. There's the same number of elementary charges now as there were before. The net charge of the whole system remained the same. I have one more example for this, and we're going to write it out. A bit more of a math problem here. If a comb that goes through your hair picks up 8 times 10 to the 4th electrons as it goes through someone's hair, what are the charges on the hair and comb in coulombs if each started as neutral? So the comb and the hair both start as neutral. The comb has now picked up 8 times 10 to the 4th electrons, which means the hair lost 8 times 10 to the 4th electrons. Since we want to know the charges in coulombs, that means we have to convert. So we have to take 8 times 10 to the 4th elementary charges and convert that into coulombs. We know that one elementary charge is equal to 1.6 times 10 to the negative 19th C. So that means we need to multiply 8 times 10 to the 4th times 1.6 times 10 to the negative 19th, and we end up with 1.28 times 10 to the negative 14th C. Now, sometimes people will say, wait a sec, that seems like a fractional charge, but it's not, okay? This is actually 80,000, again, this is 80,000 electrons. The 1.28 might look a little suspicious, but note that denominator, okay? This is evenly divisible by 1.6 times 10 to the negative 19th. If you don't believe me, take a look for yourself. So, this is the charge of 80,000 electrons. What that means is that the comb now has a charge of negative 1.28 times 10 to the 14th coulombs, and that has to be negative because the comb picked up those electrons, and that the hair now has a charge of 1.28 times 10 to the negative 14th coulombs as well, but again, that's positive on the hair. Again, we see conservation of charge. Both objects started off without any, both objects started off neutral. The net charge, if you combine the two of them, is still neutral, but each object now individually does have a charge on it. Okay, so that's charging by friction. We're now going to take a look at charging by conduction. Okay, so charging by conduction is kind of similar, except that it doesn't involve any sliding past or rubbing. Charge transferred by objects just touching. And these objects that touch and transfer charge are usually conductors. And again, we're going to do two different examples. Let's say that we start off with a neutral object, a neutral conductor. Plus, plus, minus, minus. And onto that neutral conductor, we are going to have a charged object comes near neutral conductor, causing polarization. So we're going to, let's say we have a negative rod, and that comes near and touches our object. As it's coming near, that negative object is going to push our negatives as far away as possible. So if you look now, we have a bunch of negative objects, or a bunch of negative charges on this object, and what they're seeing is, or what they sense, because obviously they can't see anything, is that this space over here is very positively charged, okay? And remember, these negative charges, they're all on this object right now, but they want to get away from each other. So what's going to happen is we're going to have some charges transfer. And the charges are going to transfer from the object that is more negative, the object that is closer to a charge of negative infinity, if you will, to the object that is less negative. Such that, in the end, we're going to have this originally negative object. It's going to have, let's say, 2 electrons left, and our originally neutral object, remember the positives aren't going to move, so they're still locked in place. But now, 2 of those electrons that were originally on our charged object have transferred over here. So notice what I've done. We've taken a negative object and we've made it less negative. We've taken a neutral object and made it more negative. This is charging by conduction, simply by touching those electrons, because there was an imbalance of charge transferred so that the balance of charge was equal. One more example, the mathematical example. Okay. So let's say that we have two metal spheres, one with a charge of positive 3 times 10 to the negative 6th coulombs, and another with a charge of negative 4 times 10 to the negative 6 coulombs. Are brought together and touch briefly before separating. What are the charges once they separate? Okay, so we have two charged objects. They're conductors. We touch them together. They each have different charges initially. What's the charge at the end? So here's a picture of what we have. This sphere has a charge of 3 times 10 to the negative 6c. This sphere has a charge of negative 4 times 10 to the negative 6c. We want to remember that charge transfers from more negative to less negative. In other words, it's very easy to see here. The negative 4 times 10 to the negative 6 coulomb sphere has more negative charge on it, so that negative charge is going to move over to this sphere. How much charge is going to move over remains to be seen. The steps with a conduction problem like this. Step 1 is to find the net charge. We do this by adding the charges, adding the charges together, taking into account the signs. And then, step 2, very easy, we divide the net charge by the number of objects. So, the net charge, remember we have to take into account the signs. The charge on this sphere is negative 4 times 10 to the negative 6th. We add to that 3, positive 3 times 10 to the negative 6th, and we get negative 1 times 10 to the negative 6 coulombs. If I were to put this into scientific notation, that's what you'd see right here. Or we can write this out as 0.000001. 1, 2, 3, 4, 5, 6. Yep, negative 1 times 10 to the negative 6. Now we simply divide. We evenly distribute that charge to the two objects. So I divide by 2, and I get negative 0.000005. So the objects end up with negative 5 times 10 to the negative 7th coulombs on each of them. The charge will split evenly. And that is actually the case just if the objects are the same shape and the same size. I believe it doesn't work if they're not the same shape and same size, but I can't remember for sure. So that's charging by conduction. That one is also pretty easy to deal with. The trickiest one is charging by induction. So we have charging by conduction, that's what we just did. We also have charging by induction. Charging by induction is tricky because there's a lot of steps to it. It happens when charge is transferred through the following steps. Polarization, which doesn't actually transfer the charge, but it's a necessary first step. And then either grounding or separation. And the key thing with charging by induction is that there is no actual touching of charged objects. which sounds confusing, but stick with me. We're going to see if we can make it make sense. We're going to do two examples again, and I'm going to draw pictures for both. Our first example, let's say that we have two neutral objects that are originally touching. So we know that these are neutral because they have equal numbers of positive and negative charges. What we are then going to do is we are going to bring in a charged object. We're not going to touch the charged object to the neutral objects, but what we are going to do is polarize each of them. So the positive charges will remain in place, but because this charged object is negative right here, that's going to push all the negatives as far away as they can get. Remember, like charges repel. Those negative charges in these conductors are going to move as far away from this charged object as they can. So they're going to come over here. So we have polarized them. This has been polarization so far. And then what we do is we separate the objects and we remove the polarizing object. So we separate the objects first, and then we take away the original polarizing object. The reason we separate them is because once we separate them, the charges can't escape back to where they started. So when we separate them, this left-hand object, we've split one object into two objects essentially, retains its two positive charges, but all the negative charges that were there have now moved to this sphere. This sphere still has its two positive charges, but now it has all four negative charges. We took two originally neutral objects and we gave them charges of positive 2e and negative 2e. Notice that the charged object we brought into polarize never touched these objects. Charging by induction doesn't involve this object touching these objects. It just influences these objects so that we end up with two charged objects. That is one way we can charge something through induction. The second way, I think the first way is pretty straightforward. The second way is a little bit more complicated. We're going to start off again with an originally neutral object. Neutral object. Okay, what we're going to do first, and let's, for this stick, let's make this a positively charged stick this time. We are again going to polarize the object first, the originally neutral object. Okay, so we're polarizing. So the positives stay in place. But because this is a positive object, remember opposite charges attract, the two negative charges in this object are going to come as close as they can to this object. So the negative charge is going to fly up here. We have polarization. The upper left side of this object is now negative. The lower right hand side is now more positive. Here's where the tricky step comes in. We're going to keep this polarizing object here, plus, 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 plus. We're going to keep everything the same in the neutral object right now, with one exception. We're going to connect what's called a grounding wire. This is the symbol for a grounding wire. What a grounding wire is it means you're making a connection with the ground, with the earth. The Earth is so big that you can treat the Earth as like a bank of electrons. And this bank has so much money, so many electrons in it, it doesn't matter if a few electrons at one particular point go up into another different object. It's still pretty much neutral. It's got so many that it's not going to miss a few. So, what's going to happen here is connecting this to the ground is going to cause electrons in the ground to sense something. The electrons in the ground are going to look at this region here, and they're not going to be able to sense that there's two different objects here. They just sense that, hey, this region as a whole seems to be electrically positive. There's more positive charges than negative charges, and we know that opposites attract. So what we're going to have happen are we're going to have some electrons, I'm going to draw 3, could be more, could be less, come up the grounding wire towards this positive region. The electrons will go up, actually I'm going to draw 4, what the heck. they come up this grounding wire towards the positive region in order to try to balance it out. And they go into this neutral object. Now, the neutral object is not touching this positive object, so the electrons aren't going to get all the way over here. So what's happening in this step is that we have electrons from the ground come in. Again, the reason the electrons are going up the wire is because they sense that this area is in total electrically positive. So they're trying to make it more electrically neutral. The electrons are attracted to this positive area, so they come up through the wire. The last step involves two things, and it has to be done in this order. Remove the ground, and then the polarizing object. You have to cut the grounding wire first because that will trap the electrons in this object. Then you can take away the polarizing object, and what you're left with is this. Those positives haven't moved, but we've added 4 negatives. And now this object is electrically charged. It has a net charge on it. Okay? Again, it's induction because the original charged object never touched the neutral object that we eventually put a charge on. Okay? That is charging by induction. There's 2 different ways to do it. So overall, we've looked at the 3 methods of charging. Charging by friction, charging by conduction, charging by induction. In the last video, we're going to take a look at an electroscope, which is a tool for detecting types of charge. And then we're going to take a very brief look at electrostatic force, and then that's pretty much it for the videos for this unit.